We're going to begin a series of videos now looking in more depth at radicals and how they work. You've been exposed to radicals a little bit in the past. For example, if I write this expression, which we say is the cube root of 8, and we want to know what the answer to that is, we know that that statement means that we're looking for something which when multiplied by itself 3 times would give us 8. And if we think about that, we see that the answer would be 2. The third root of 8 would be 2 as we say it. So here's a general definition of an nth root. If we have a real number and a positive integer n, then x is an nth root of a if x to the n equals a. Which sounds technical, but it's exactly what I just said, basically with my example. If I have x to an exponent n equaling a, we can write that in radical form as the nth root of a equals x, which means we're looking for the number which when multiplied by itself n times would give us the value of a. And just some definitions of the parts of the radical. This entire expression is what we call a radical expression. The number under the radical sign is the radicand, and this little number here, n, is always a positive number, a positive integer, and that's called the index. Now, when you're working with radicals, there are some technicalities and restrictions that you need to be aware of. So I want to walk you through some of these sort of step by step and case by case. So if we have the nth root of a, the first situation I want to look at is when we have a positive radicand and an even index. So that would be situations where we're dealing with a square root, a fourth root, a sixth root, any place where n is an even integer. So in the case of a square root, we know what we'd be looking for to get the square roots of 16 are the numbers which when squared would be 16. And if we just think about that, we can see that 4 squared is 16, and negative 4 squared is also 16. So we have two square roots, negative 4 and positive 4. And so x would be, our nth root would be the square root of 16. Now here comes our first technicality. This symbol on its own represents what we call the principal root, which is the positive root. And since there are two of them, in this case, we have to say plus and minus the square root of 16, which gives us our plus or minus 4. So we have two square roots. And this issue of two roots will come up anytime you're dealing with an index which is even, fourth roots and sixth roots. So let's just look at these. Fourth root of 16 means that something to the fourth is 16. And again, we can see that there are two situations here. We could get 2 to the fourth is 16. So we can get the fourth root of 16. But this symbol represents the positive root only. We could also get negative 2 in brackets to the fourth to be 16. So we have two roots. So we need to say plus or minus to get our plus or minus 2. And same thing with sixth roots, eighth roots. Any time when the index is even, we're going to have two nth roots. So we represent that as plus or minus the sixth root of 64, which in this case is plus or minus 2. All right, so an even index with a positive radicand results in two nth roots. But the radical symbol itself on its own, the sixth root of 64, just on its own, represents the positive root, the principal root, as we call it. All right, what if we have an even index with a negative radicand? So if we have the square root, index is 2 on square roots, remember, of negative 16, or the fourth root of negative 16, or the sixth root of negative 64. And if we think about this, whenever we have something to an even exponent, that answer is going to be positive. So you're not going to have roots for any of these scenarios. So anytime you have a negative radicand with an even index, your answer is going to be undefined. There are no values, which when raised to an even power will produce a negative. All right, so we've looked at all of the situations involving even indices. Let's now look at scenarios where we have an odd index. A cube root, a fifth root, a seventh root, that kind of thing. So if we have a cube root of 8, that means we're looking for something to the third power, which is 8. And in radical form, that would be the cube root of 8. And if we think about that, there is only one possibility as an answer, and that's 2. So third rooting a positive radicand gives us one answer, which is different than what happened when we took the square root, fourth root, sixth root, even root of a positive value. Can we cube root or fifth root negative values? That would mean that x cubed equals negative 8 in this situation. X would equal the third root of negative 8, turning that into radical notation. And is there a number which when raised to the third power would produce negative 8? And there is. In this case, it's negative 2. So our root is negative 2. We are able to cube root negative values. We were not able to square root, fourth root, sixth root, even root negative values. But we can do it with cube roots. And fifth roots, as you're going to see, x would be the fifth root of negative 32. Is there such a number which when multiplied by itself 5 times would give us negative 32? Yes, negative 2. There is a root. So you can nth root negative values if your index is odd. And the final scenario that we have to consider is square rooting 0 or third rooting 0 or fourth rooting 0. Is this possible? Is there something squared which gives us 0? Is there something cubed which gives us 0? And in all of these cases, the answer is 0. Okay? All right, so to summarize these important points about nth roots, if we have a positive radicand and an even index, we saw that there were two answers, two real roots. But this symbol represents on its own the principal or positive root only. So the fourth root of 16, that symbol on its own would represent 2, even though 16 has two fourth roots, 2 and negative 2. Situation number 2, if our radicand is negative and we have an even index, we saw that it was not possible to nth root an even root, so there was 0 real roots. In the next situation, we had an odd index, and if we had any number as our radicand, we were able to come up with an answer, one answer. And that one answer is our principal root, whether it's positive or negative. We always got one answer. If our radicand was positive, we got a positive answer. If our radicand was negative, we got a negative answer. And our fourth scenario was if our radicand was 0, nth rooting 0, whether n is even or odd, always produced an answer of 0, and so there was one real root.